Good morning. Can you all see the screen?
Yes, sir.
Okay. So today's class, I'll be showing you the demo how to run the linear regression, how to predict the end outcome of the linear regression, right? So last class we have discussed about the basic types of regression and the types of machine learning, supervised and unsupervised. In supervised, what do you mean by classification? What do you mean by regression? In regression, there are three types of regression: linear regression, logistic regression, and polynomial regression. Linear regression always go with your continuous values, whereas your logistic regression, it will go with your categorical values. It's like either a 0 or 1 or true or false or yes or no pattern. Whereas your linear regression, it will go with your continuous value like your price, age, temperature, your salary, something like that. Then the third one is your polynomial regression. Polynomial regression, it is always go with it does not depends on the predictor and response variable. It always depends on the coefficients. Y is equal to ax plus c, bx plus c, then y is equal to bx plus c, bx to the power 2 plus c plus bx to the power 3 plus c. So it always go with that coefficients, right? So that is what the polynomial regression. The outcome of that linear regression is always a straight line. Your outcome of your logistic regression always it is like a type of S curve, sigmoid curve. We used to call sigmoid curve, S curve. Then third one is your polynomial regression. It is always go with your any type of C type of curves, right? Because the values are scattered across the plane, so it will go with the different types of curves. So that is a polynomial regression, where whenever that coefficient, the power value changes, so the values may be scattered across the plane, so that it will go with the different types of curves. This is the polynomial regression. So these are the three different types of regression in machine learning. I hope you understand the basic. So what we will use, how the outcome. So we will use for continuous value, here categorical value, there also it is multiple coefficients. Then there is a difference between your linear coefficient and multi-linear coefficient. In linear coefficient, we will predict the result based on one variable. Suppose if you predict the outcome based on multiple variable, one or two variable, for example, I want to predict the tomorrow's temperature, so or next year temperature, then that depends on different parameters, year, month, that the environment and the humidity, nature, everything, right? So that depends on multiple values. Now I want to calculate the salary based on the employee. So then the employee salary experience is the one of the one column. So it depends on a single column, single variable. Then that you can, in that case, you can go ahead with the linear. When there will be a multiple variable, multi-variable dependency, that we will go with a multi-linear regression. Generally, linear regression, this will be suitable for all your regression problems, linear type. When you go with your logistic regression is suitable for maximum, it is suitable for classification problem. Even though we'll go with regression, but majority we will go with classification problems. That is what you may not see maximum things in not in I mean logistic, only in linear. Okay. So if not, we'll go with your polynomial regression. So this is what the outline of this module 2. I hope you understand. So with this, we will proceed further. So what is, I want to just recollect the previous content. What is a regression? Regression is simply a prediction, right? So how do you predict? So prediction is meaning you need, say, there is a dependency. What do you mean by dependency? There is nothing but a relationship between two variables. That is what regression is all about. So when you say machine learning always it will go with a statistical modeling based on mathematical support. So here that relationship is used to predict the outcome of the future events, right? So classification, what we will do, you will classify the things, but whereas in regression you will predict the things, right? So that is what regression is all about. So you can see this diagram, regression, the basic difference between your linear regression and logistic regression I given. So this linear regression, it will go with in a straight line manner. So it will predicted y can exceed with the range from 0 to 1 range. X axis your independency variable, then y axis your dependent variable. So what do you mean by dependent independent? If you say y is equal to mx plus c, so this x is nothing but your, we used to call predictor variable, or we can say it is your independent variable. But whereas y is called response variable, or else you can say dependent variable. So y result outcome is dependent on this x. So this is what this your dependent variable, independent variable, right? Now, so if the result is a straight line, then you can say it is a linear regression. If the result is like a S curve type, then you can say it is a logistic regression. Now, today's class we will see linear regression, and tomorrow's class we will see logistic or multilinear regression. What is a linear? So linear is used to predicting the continuous dependent variable with the help of independent variable. That is the purpose of your linear regression. So this linear regression is one of the type of your supervised machine learning techniques. So what is the goal of this linear regression? The main goal of linear regression is to find the best fit line that can accurately predict the output. So we need maximum accuracy in any prediction, right? So that is what. So this algorithm always gives you the best fit. Then there are two types of regression. One is, I told you, simple linear regression, multilinear regression. Simple linear regression always the result is depend on the single independent variable, whereas multiple linear regression depends on more than one independent variable. Then we can say it is MLR. So what we will do, in order to find the best fit line algorithm, we can establish the relationship between dependent variable and the independent variable. So you can establish meaning you need to create a relationship between these two variables in terms of machine learning. So always this relationship should be in linear in nature. So that is the main important. The output of the linear regression should be only a continuous value such as your price, age and salary. It is a discrete, right? So it is fixed values. The relationship between the dependent variable and independent variable can be shown below. So you can see this is your experience, this is your salary. The same 2 years of experience candidate, there are different candidates, they are getting different salaries. What is the best fit? You need to find out this one, whereas whatever the points are sitting on that line, so that is your best fit, that you need to identify. So what is that best fit, right? We'll see. So the same thing is explained here. So when you say logistic regression is most one of powerful technique for supervised. At the same time, it can be used for classification as well as the regression problem, but mainly used for classification. As I told you, logistic regression is used to predict the categorical dependent value with the help of your independent value. The output of the logistic regression can be only between 0 and 1. So either from 0 or either from the 1 maximum. So logistic regression is used where probabilities between two classes is required, such as whether it is will be a rainy today or not, either 0 or 1 or not, or true or false or not. So that is your logistic regression. For the this logistic evaluation is based on the concept of maximum likelihood estimation. That is one of the evaluation parameter. Finally, this is going to be a evaluation. The activation function is known as sigmoid curve. So this is sometimes called a sigmoid curve or S curve. So this is what this pattern is all about. So this is 0.3, this is 0.8. So maximum between it is a 0 to 1 is your curve type values. So this is the difference. This is the same difference which I explained in the module 1. So you can read it later. Then the next one is polynomial expression. So polynomial regression, as you know, this is the regression algorithm that models the relationship between a dependent variable and independent variable as nth degree polynomial. That is very important. So this is your nth degree polynomial. So it will start from the 1, 2, 0, 1, 2, 3 and it will end up with your nth degree. The polynomial regression algorithm is also called polynomial linear regression because it does not depend on the variable. Instead, it depends on the coefficient which are arranged in linear in nature. That is what I told. So even though it is nothing but b0 plus b1 x1 is nothing but it is 0 by default x0. So whenever by default by default a linear regression, logistic regression, also a polynomial regression because the x to the power 0 or 1 it does not affect anything, right? So that is also by default it is one kind of polynomial regression. In this example this curve is shows, so if you want to generate this type of curve then this we can go ahead with only polynomial regression. This straight line red curve is nothing but your linear regression, right? So you can see the equation of polynomial regression. So the simple linear equation, as we know, y is equal to b0 plus b1x, right? Multilinear regression is nothing but it will go with like this x1, x2, x3 until xn. Polynomial regression equation nothing but x squared and x to the power 3 until x power n. So this it will go like this. So if you compare these three equations, you can see easily the polynomial equations are differs by their degree of variables. Here x to the power 1, x to the power 2, x to the power 3 up until x to the power n, right? So this simple and multilinear equations also a polynomial equation because with a single degree. So it has one degree x to the power 1, it does not affect anything. So this is also a polynomial equation and the polynomial equation is a linear equation with n degree. So if we add the degree to our polynomial equation then it will be converted into a polynomial linear equation. That is what. So finally when you see all these three types are considered as the polynomial linear regression equation, right? So that is what polynomial degree equation. Now okay, now this is what intro about all the three types. Now let us move on to the linear regression. First I'll just give you a simple logic behind this linear with one problem, then we will move on to the main problem. Now assume I have a two columns, right? So quantity and price, so keep that away. Then now you want to do a shopping at Walmart, Guntur Walmart, assume. Now whether you buy goods or not, okay, so when you enter into the gate, whether you buy goods or not, you have to pay $2 for parking a ticket, okay. So previously, even I went recently last week Guntur Walmart. Even previously, even though if you go and buy or not, but you can enter into the Walmart and you can do window shopping and come back. But so the recent days they did a minimum purchase of 1500 is must from the Walmart. If you enter into the Walmart main gate, you must buy something. You cannot go. Previously, you can buy either you can buy or you can come. You can't buy. Sorry, if you won't buy, no issues. But now minimum purchase is 1500. Similarly, there is another Walmart. They introduced like whether you buy goods or not, but you have to pay the $2 for parking ticket. Okay. Suppose each apple price is $1.5. So I am planning to buy only apple. So I am entering into the Walmart by paying the $2 ticket for parking. Now for each anyway while come returning only we are going to pay. So that is an asset matter. So each apple price is 1.5 and you have to buy an X items of apple and then we can populate the price list. Okay. So now so when I say I need to buy apple, suppose I am buying apple, y is equal to, so if I buy apple, apple rate is 1.5, so into number of items, number of apples, so that is 1.5 into x. So whether I buy or not, as per the logic, I need to pay $2. So 1.5x into 2. So that is my parking price. So by default, suppose if I buy one apple, y of 1, if I buy one apple, so what will happen? 1.5 into 1 plus 2 is equal to 3.5. So if I buy one apple, then I need to pay 3.5 rupees. If I buy two apple y1, this is y2, then 2 apple 1.5 into 2, 3, 3 plus 2 is 5. So we need to pay $5. Right? So in such a way we prepare this table. So we know, so for when you buy one quantity apple, you need to pay 3.5, 2, then 5, 3, 6.5, 4, 8. So this is what the, now the table has been formed. Okay, got it? So now the question is, I told you this. So now the question is, now you can visualize this table. This is the table. This is the graph given as per the table what we created. So now if I won't pay, if I won't buy anything, then even though I need to pay this $2 parking price, right? So now I am buying a single apple. So I am buying, this is 0 to 2, in between 1. So I am buying a single apple. Then it is nothing but I told you it is 3.5. So if I buy 2 apple, then it will become 3 plus 2, 5. So this is nothing but my 5. 4 in between 5 and 6. Same, I am buying 3 apples. So I need to pay 7.5. So now, so similarly, so this graph is generated. So this graph is generated based on the quantity of apples what we buy, right? So now my question is, now I am not buying any apples now, right? So what will happen? So see here, where is this graph? Yes, now. So now this is 2 rupees ticket. Suppose if I am not buying any apple, then what will happen? Then y is equal to 0 plus 2. So you need to pay, by default, you need to pay the parking ticket. So in this case, what will happen? So suppose if a is equal to 0, suppose I am not paying any parking ticket. So in such cases, what will happen? If a is equal to 0, this parking rate is 0. What will happen? You have to no need to pay for a parking ticket. The shopping cost line will shift down. They are still in a line of orange color. You can see here. Suppose I am not paying any parking ticket, or else I am not. If I am not paying, if I am not buying apple, then what will happen? Parking ticket is 0. Suppose if I am not paying for parking ticket, then the constant value y is equal to mx plus c, the line equation. So now this is a constant. So this constant is nothing but here the parking ticket. So suppose assume I am not paying any parking ticket, then this c becomes 0. So now y is equal to mx. Suppose if I buy one apple, then I need to pay 1.5. If I buy two apple, then I need to pay 3. If I buy 3 apple, I need to pay 4.5, 6, 7.5, 15 and 16.5. So this is only apple cost. This is including with parking cost. So now if I draw a line for with parking with only apple, see there is no much difference in this graph. You can see this blue line is says with parking cost 1.5x plus 2. So this orange line is just 1.5x. So we are multiplying with some parameter 1.5 into x. Whenever x value changes, is gradually it will increase. where x is equal to 1, 1.5 into 1. When x is equal to 2, 1.5 into 2. So obviously it will gradually increase. So that is what, when even if you connect, then that is also become linear in nature. So now, so the logic behind this is, so this both the values are by default, it is linear in nature because it's gradually increasing, right? So this is what this linear regression example. By seeing this value, you can say it's gradually increased. This is in this application side, but it's in real life. Can you think, is it easy, that much easy? Maybe that is not that much easy. So what we will do, so we will take there, because there may be a values here and there. Values may go above, sometime may values may go down below sometimes, right? So apple rate is by default we kept is 1.5. Sometimes it may go down. So in such cases, what we will do, we cannot do anything, right? So that is not possible in real time. So so what we will do, we can either adjust the value within that range. Maybe it may be slightly, it may go increase, or slightly it may decrease, but the value within the range. Today tomato is 20 rupees, tomorrow 18, or then day after tomorrow it's become 21. So so what we can say, that maybe the tomato values between 18 to 21, but it may not go beyond. So in future, what I can say, I can, if I ask you to fix the rate for tomato for the next month marriage time, if I want to commit with the vendor, what I will do, then the value may be, by the time it may be 19 or 20. So something like that. So that is what we will fix. So the range. So this will happen in real time. So that we will see in this example. Now, I want to estimate the salary of an employee based on their year of experience. So this is the task given to you. So, for example, here, even you take our university, how the employees are identified, after identification, how the designations are given, after giving designation, how the salaries are given, how the salaries are fixed. So now the salaries are fixed based on the experience, year of experience, right? So now you have a recent company data which indicates the relationship between experience and the salary. Here, experience is the independent variable. Keep that in mind. Here, the experience is the independent variable. Assume that is X. The salary is a dependent variable. Assume this is Y. The salary of an employee is dependent on the experience. Yes, I told you Y is equal to mx plus c. So salary of an employee is dependent on the year of experience. So now, using this insight, using this scenario, you can predict the future of salary of an employee based on the current and past information data. So this is what the data is given. If suppose if it's 1.1 years of experience, then he will get 39,000. Right. Suppose if he is the 5 years of experience, then he will get 66,000. If he is 10 years of experience, he will get 1.21 lakhs. So similarly, now if whatever the number I give, so whatever the number I give, the system used to predict my experience, predict my salary, right? So that we should calculate it. So now, right. So it was struck. Okay, yeah. So now the scenario is, you are a HR officer. You got a candidate with 5 years of experience. Keep that in mind. So you have a profile with 5 years of experience. What is the best salary you should offer him? So that is what the question is given to you. So what we will do now. So now what we will do, before doing any calculation, so first we will draw the graph, how it looks like, because the basic predictions, let's do it. So now this table is given. So year of experience is in your, I told you it is your year of experience, your dependent parameter, sorry, independent parameter. Y is your dependent parameters, right? So Y is in exact, Y, where is it? Pen. So this is your x-axis, now this is your y-axis, right? So Y is your salary. So X is your year of experience, sorry, yes, year of experience, okay. So now when you plot a graph for this table, for this graph, so the values are scattered here and there, right? In previous case, you can see here, in this case, the graphs are straight line for simple scenario, but because the item value is not changed there in Apple cost, but here experience are changing. So now you can see the values are, you are getting different salaries, 1.1 years, 1.2 years, 1.3 years experience, right? It is not like your a fixed value, it is like your continuous value, 1.1, 1.3, even 1.4, 1.6 months, 1 year 6 months, 1 year 7 months, then what is the value? So it is very difficult to do it manually, so you need kind of learning algorithms, right? So now, but by seeing this, will you say this is a linear? So we cannot say this is linear, but you can predict. What we can do is the observation. These are all we used to call observation. So by seeing this, you cannot predict the y value, but only one thing you can see, if you close, if you look this graph very closely, you can see this graph is looks like a line. This graph is looks like a line, but in little variations, little bias, right? Little error. But you can see, that's what I just mentioned here. Please look at this graph carefully. We have bad news. All the observations are not in the line. It means we cannot find out the equation to the calculated y value. So what we will now, if you do it, if you look scatter plot again very closely, all the points is not in the line, but they are in line shape. That's what I told. So they are in the line shape. So what we can do, the salary range of 5 years experience is maybe some, I may not predict this correct point, but I can say this anyway, this 5 year, for example, 5 years of experience is here. This 5 years of experience fellows range is either from this end or this end. So only within this range only. So I can easily, then I can easily find out. Then what is this range exactly? So we can say the salaries varies from the upper half to lower half only, right? So now, so how you offer the salary? So based on our observation, we can guess the salary ranges of 5 years of experience should be in this red range color. So we can easily guess. So his salary, it may not go more than 82,000 or lesser than 60,000. So then what is his salary, perfect salary? So what we can do? So now we need obviously a machine learning algorithm to predict the best salary for that candidate. So what is the best number, perfect number? So between this 82K to 60K. So how do you guess? So that is why you need a machine learning algorithm to predict the best salary for the candidate. So that is where we will use your linear regression. Since it is the values are continuous values, so you can go with your linear regression. So now this linear regression always go with 5 steps. Just I'll show you the steps. The first step is importing the data set. Your first step is of your any regression is importing data set. Then split the data set into 2 halves. One is for training, another one is for testing. Right? So for a training, either 1/3 is for training or 2/3 is for training is sufficient. So for example, I have 30 observation. Either I can take 10 observation or 20 observation for training. But you should not take this. You should not take the same duplicate copy for training because accuracy may not increase. So it should be a diversified data. Then the third one, after once importing over, splitting over, then third one is visualize the training set. You need to do the graph, visualizing the training set and the testing set. Okay. Then finally, you generate your regression model. Finally, you train your model through regression. Then you can predict. So this is what the 5 step of your machine learning algorithm. So now let us move on to since it is a first class, I just kept the codes in the step by step. You watch carefully the same source code for the all the regression algorithm. Only the keyword changes. So before moving on to the linears, we summarize 2 basic steps. One is, as you know, training set. Another one is a testing set. Training set is for learning. Testing test is for prediction outcome. So in this linear regression problem, we will use 4 libraries. One is your NumPy, another one is your Panda, then the third one is for your sklearn, then the fourth one is for a matplotlib. So matplotlib library. So we are going to use 4 libraries. So NumPy and Panda is always used to work with the data set. So to support the data set, NumPy and Panda. So the sklearn or skylearn are kind of other libraries to implement machine learning function. All your regression, whatever the machine learning algorithm you use, so you need one library for that. Either you can go with a skylearn or a SAlearn or a sklearn, whatever it may be. Then another one is matplot library. Finally, you need to visualize the output, right? So to in order to draw the output, in order to plot the output, so you need one library. So matplot library. So these are the 4 libraries you need, right? NumPy and Panda for importing data, SK for machine learning, then matplot for your final drawing. So now you can import these 3 data sets. So the syntax, I think you have studied the Python, right? Python. Have you completed Python course in the first year?
No, sir.
Python. No, sir. Then what you completed?
Java.
Then when will you study Python course? Without Python prerequisite, then how will you take machine learning course? What is the prerequisite for this course? Oh my God.
No prerequisite.
There is no prerequisite.
Oh. Python should come in the 3rd year actually. So wait here randomly they're giving. Okay. So okay, then you watch it closer. So import is a keyword. The red colors are keyword kana. So import NumPy is my library. So there are different libraries are there. So when you study Python, so there are two views of Python. One is the data structures. Python data structure, listed, set, dictionaries, all other list, again array, vectors, etc. Right. Another side is how to use the libraries for your machine learning, deep learning kind of, right? So for your statistical modeling process. So now we are focusing on the second half. We are not doing a proper hard coding using Python and all. We are using libraries, right? So now this import is the function. Import is the keyword where it will help you to fetch the necessary library and it will load you into the your dashboard, you into your this panel, right? So import NumPy as is a keyword. Instead of using NumPy everywhere, I can use NP. It is like alias. Okay. So Karthik versus something like Gautam. So something we will give. No, that is what as is nothing but alias. So import NumPy as NP, then import matplot library dot pyplot. Matplot is under pyplot, Python plotting library. So under this is the main file. So main library dot sublibrary. So matplot library dot pyplot as PLT. I am using PLT. Then import pandas as PD. So I can use directly PD. So now what I need to do is first I need to import the data set. So then what I need to do, so I can use some local variable data set is equal to pd dot read csv. So panda I am using panda dot pd, that is what I told, this pd dot read underscore csv. So I have a csv file, just I'll show you. I have csv file. Keep this. So where is my csv? Module 2 simple linear regression. See, I have the csv file here. I can see year of experience and salary. So I kept 2 columns. So this is what my data set. So default data set. Now I need to import this data set. So what I am doing, pd dot read csv salary underscore data dot csv. csv is the file name, comma separated value file, that is what csv file, or else we can use your excel, right? So whatever the file name is, you should use properly xlsx. Now so once that now the data set is loaded, assigned to the data set variable called data set. Now I need to read the file, read the content from the data set, right? So how do you do? So that if I read the columns values from the data set, so that I can assign it to the local variable. So with that I can play, right? So y is equal to mx plus c. So I want to know what is this x and what is this y. So now I am saying x is equal to, so this data set of, now the value is assigned to data set. So data set of dot ILOC, so right, ILOC linear curve. So it represents the linear regression curve. So now what I am saying, so colon comma colon minus 1, colon comma colon meaning, so from in the Excel sheet, if you see the data sheet, from the first row to last row, so beginning source comma destination, so source 0 to n, minus 1 meaning, so I want to take all the rows except the last column. So then meaning, so I have 2 columns, one is year of experience, another one is salary in the table. So what I am saying, you take only a first column, leave the second column. That is what x is nothing but, because I want to assign x to this one only, no? So now, so last column, so the get a copy of data set, exclude the last column, the salary is gone. So this x is nothing but my year of experience. Now y is nothing but salary, because I need to predict. So now y is equal data set dot ILOC comma the only one column is nothing but my salary column, the second value. So one is nothing but get the array of data set in the first column, whatever is there in the first column it will take. X is the first column which contains the year of experience. So year of experience goes to this one. Y is the last column which contains the salary of the array, right? So now this is not the first, this is second, right? So this will take the last column of that data set. Last column of data set is nothing but my salary. This is what it will take, right? Now x and y is assigned. Now how to play with this x and y? So slowly you understand, data is somewhere, you are importing the data, then you are reading the content from the data set, so you are assigning to local variable. Now x and y is assigned. Now what we need to do, now the third step is to need to you need to identify the training set and test set. So now how do you split? So I am splitting by, so now before splitting I need to introduce that split variable. So from sklearn dot model selection, so I am keeping a variable named dot model selection, import train underscore set underscore split. So I'm just importing train underscore test underscore split variable. So this has a function of x comma y comma test size comma random. X is nothing but, we know x is nothing but year of experience, y is nothing but salary, the size is nothing but 1/3, meaning 1/3 of observations are used for your training. Suppose assume the training set is, the test set is 30 observation, then 10 observations are will put for the test case. So if you can put 1 by 2, then it's nothing but 50%, right? So then the random state is nothing but it is used to generate the random numbers for each test case. So this is the optional one. So either you can put 0 or you can give the values. So now this will be assigned to X is assigned to X train, Y is assigned to X test. Then again, test set is assigned to Y train, then random is assigned to Y test. So now what we will do, so now we need to find the regression. You need to build the regression model. So how will you build? From sklearn dot linear model, import linear regression. So you need to import the linear regression. Then finally regression equal to linear regression of is our training model, default model which is already implemented. So you need to call the linear function. Now you need to start the training process. How do you train? The function is this regressor is a local variable, regressor dot fit, because you need to identify the best fit, right? Best fit, whatever the points which are fitting on that curve straight line, you need to keep that, remaining should be eliminated. So now X train comma Y train, we are already trained here X train and Y train, these two variables, right? Point color. So this X train and this is your Y train. So you can see here. So now X train comma Y train is your, X train contains year of experience, Y train contains a particular employee salary. So this is your training process. Now the last step, as I told you, visualize the training set results. First you need to visualize the training set result. Finally you need to test set results. Training set before learning, test set after learning. So same. So for plotting, what I need to use? For plotting, I need to use matplot. So see here, matplot is nothing, very local variable, nothing but PLT. So I need to use PLT first. So I am assigning PLT to wish train. Wish train is nothing but your local variable. So now wish underscore train dot scatter. Scatter meaning first I am scattering all the points in the plane. So X train comma Y train comma color is equal to red. So red is nothing but red dots will come. So you can see this diagram, you can understand. See this red dot. So this is your scatter plot. I mean just scattering the observations. Now train dot plot. Now this is the I am plotting X train comma regressor dot predict of X train comma color is equal to blue. So I am just drawing the linear regression. The using regressor dot predict of X train. This predict of X train is nothing but this train. So whatever the value we predicted connected, whatever the values are in the line, so it will connect. Now, so I am keeping the title to the graph salary versus using title variable, title of salary versus experience. Then I need to keep some name of that x-axis and y-axis. X-axis is year of experience, y-axis salary. So that's what I'm keeping, x label, y label. Finally, I need to draw the graph. So train dot show off, that will be shown. Same logic. When I visualize the test result, keep PLT. Instead of test result here training, you have kept X train. For testing, you need to keep X test. So remainings are same. X train, Y train, whereas here X test, Y test. You can see here. See here, this is X train, Y train. Here this is X set and Y set. Remainings are same, right? So similarly, if you do this, you will get this. See here, the first one, the training set, all the graphs are plotted, but whereas test set, so only the fitting points were plotted. Remainings are, so just how it is eliminated. Majority of eliminated, 1 or 2 is there, that will be outliers. That is also we can eliminate. So these are the points are the best fits, 1, 2, 3, 4, and 5s. So this is what the compared two plots, we can see two blue lines are there in the same direction. Our model is good to use now, right? So now this is how visualizing the graph. Now I want to do the prediction, the main part, the main conclusion. Now I want to calculate the 5 years of experience fellow salary. What I can do, y prediction is equal to regression dot predict of 5. So predict is nothing but your variable, x variables. Predict of 5, year of experience is 5. So when I say year of 5, the salary you can say 73,500, 545. So this is my salary. So he can offer 73%, 73,545. So this is the best salary for this person x when x is equal to 5. Okay, this is what your linear regression is all about. So instead of passing here a single variable, can I pass array of variable? Yes, I can pass array of variable. You can take the x test. X test case meaning whatever the experience are there, that will be passed to here. So you will get that salary here, right? So that is what linear regression is all about, right? So just I'll show you the demo. So you can see, just to see, I don't have time. I think 11:50. It's at 12:50. So I'll just open my Colab, Google Colab. You try to either adapt with Google Colab or Jupyter Book. No, nothing, both are same. Just I'll opening my Google Colab. So open. I just already executed ML demo. So here I am keeping my programs into my you can see in my drive I created my drive under ML demo files. I just kept salary underscore data and my file name simple underscore linear underscore regression file. So now this Jupyter book, yeah. So now I am using my Colab. Where is it? Yes. So now I just opened that file name. So you can see here, let me run this. First I'm mounting my drive, Google Drive, so that I no need to set every time. Mounted Siri, change directory, yes, permission. Now I am listing ls, how many files are there in ls. I have salary underscore data.csv, simple linear regression. So I am just running the same. So you can see this same code. I just copied the same from here only. I just taken from the PPT. You can see the library were included, same data sets were included, same training were done. Again, regression model were done. Again, I'm predicting and finally visualizing. So this is what. So now you can see the graph. So how it looks like, right? See, this is a training set. This is your year of experience. Now we will do that. Where is that code? Now if I do y prediction of what is that value here? Year of Here already we are predicting y predictor. Okay. Y underscore predict PRT regression dot x set. Suppose if I give 5. This is the value error. Same print. Okay, let me check that. Okay. So see, this is how finally your graph is visualizing the linear regression is all about. Okay. So I'll upload this code into this chat box, so you can even try in your home. Okay. To
Sir, can we run this code in online compiler?
yeah. You just to open the default notebook. So just I've posted in the chat box. You can use the same CSV file and notebook file. Okay. If you want Python file also, I will give. So just you can use simple any regression. So here, if you go and download as, if you download.py, the same program will be downloaded in Python. If you download py.pnb, the file will be downloaded in notebook. Okay, that you keep it. Download both the format. So that is this. So because in Colab it may not open Python file directly, some integration issues, you need to mount your direct drive. So you keep both the files, notebook file and Python files as such, so that. So okay, thank you. So next class we will see logistic regression. Okay. So let me download the attendance. Okay, you can leave. Thank you.